So good morning, distinguished judges. Hope you are enjoying the sunshine in Las Vegas. We're also from a sunny city. We're Team National University of Singapore. So as all successful project teams, we have a good-looking project manager and creative data engineer Zijing and a smart data scientist Mingzhou. So I believe most of the team has covered the background and the context of the project, so I will skip that part. So here's the overall approach we have taken. So we studied the data provided in detail, and we broke down the tasks. These two parts will be covered by me. And then Zijing will talk about how we constructed the variables, and Mingzhou will elaborate on the modeling and the results. So moving on to task understanding. We need to predict the sales for each variety using historical experiment data and sales data. So based on that, we can select elite varieties according to the 1 million rules. What's more, we should also be able to come up with some quantifiable rules that can be reused in the future. So with this in mind, especially the last task, we strive to achieve both accuracy and interpretability. So moving on to data understanding. Ideally, we would like to have data at each location in each year for every variety. However, data is only available at selected location for some, in selected years for some varieties. And what's worse is that only 31 of the varieties has historical sales data available because they are the only ones commercialized during the past 3 years. So the key challenge for us is the data sparsity issue. So with the clear understanding of the tasks and challenges from data, I would like to pass on to Zijing to talk about how we constructed the variables.
So we like to predict the sales of our soybean seeds. Let's think about it. What affects our sales? We identify 3 major factors: macroeconomic, market competition, and the variety characteristics. For macroeconomic, I'm referring to things like annual GDP or the supply and demand in the market. So to measure this, we source the data from US Department of Agriculture, and on their website, we obtain data about the predicted soybean production volume in the US. So this is a good indicator of the demand for our soybean seeds. As for market competition, it will be things like the competitors' products or their marketing strategies. We assume this didn't change over the years, but it would be good if we have more information about that. The variety characteristic is the major factor we are focusing on. So in the data given, we have the information about relative maturity and the experimental yields. Let me elaborate more on how we create variables from the yields data. As we know, yields is determined mainly by the seed quality as well as some environment factors such as soil condition and the weather. We want to control for these environment factors and then compare the seed qualities. Ideally, we want to have made the comparison between the variety yields at the same location and the same year, this kind of combination. But however, given the sparse data, we are not able to do that. And then, if we just compare the absolute value of the yields for different varieties at the different location or year, it won't be a fair comparison. So imagine we have these 2 groups of seeds that is planted at different location and year. We can see that maybe the blue group is planted at a more amiable environment, and naturally they will have a larger yield. So we might arrive at the conclusion that the blue variety is better than the diamond ones because they have higher yields. But is that true? We think that it will be more reasonable if we use the relative yield, which is adjusted by the group average. So we can see that actually the diamond ones are the better ones because they outperform the peers under the same environment conditions. So after we have adjusted, controlled the environment factors, we'll show you how we measure these seed qualities. The data given to us is the experiments of different varieties, and we want to compare the cells of different varieties. So it will be natural for us to aggregate the experiment data by the varieties, but we observe that some of the varieties have very few measurements. So we want to add one more layer of the aggregation to the family level. In this case, we will give up a bit of granularity and have a much larger data size, which can be better represent the characteristics of these varieties. And last but not least, we always want to keep our customers in mind. When the farmers buying seeds, what are they looking for? And they want good yields, but at all times. This means that they are not only looking at the yields, but also how stable the yields are. So we need to measure the average yield as well as the variation of the yields. So in summary, we have prepared the data for our models, and the final data set consists of 31 rows, with each representing one commercialized variety. And we have 6 predictors, which we just constructed: the predictive production, the relative maturity, the variation and average yields for the varieties, as well as the average and variation of the family yields. And finally, our target is the sales of different varieties, which is measured by the number of bags sold. So now I'll pass on to Mingzhou to talk about our models and the findings.
Thank you, Zijing. So, with the variables in mind, I wanted to first talk about what model we have selected. So, our objective is to have both accuracy and interpretability. So, our first model chosen is Lasso. It's mainly chosen because due to its great interpretability and a certain level of accuracy. Remember, we may have constructed some variables that are correlated with each other. So Lasso is able to handle this issue pretty well. Our second and third model are random forest and gradient boosting machines. And these two models are pretty accurate, but they also have certain level of interpretability as well. What's more important is that they can handle the potential variable interaction as well as some nonlinear relationship between our cells and our variables. This is a good complement to our first Lasso formulation. We also experimented k-nearest neighbor, but they are discarded mainly due to their low accuracy. As for artificial neural network, since we only have 31 data points, it is out of the equation as well. So we arrive at our final model that is an ensemble model of the period 3. And our final prediction will be a weighted average of the results from the period 3 models. And we determine the weights assigned to each model by minimizing their errors in cross-validation. So I have talked about the model we have selected. We also face some challenge in tuning and testing those models. Since we only have 31 data points, how can we properly do a cross-validation? Because the size of the data is so small, the cross-validation result is going to depend on how we assign our data points to different training and testing data. And the solution to that would be repeat that for 1,000 times and randomize the assignment to different folds. And by that, we can compute the average performance, and it will be a more objective measure of the performance of the model. So we have built our model, how good they are. With the final ensemble model, we are able to identify 4 elite varieties with a predicted sales of over 1 million. And our final model is able to explain up to 69% of variation in sales in out-of-sample measure. That is, we computed the average across the 1,000 times of cross-validation, and we compute the R-square out of sample that is in the testing data. So our model is pretty accurate. But remember, we also want to get some insights from the prediction, not the result itself. Our first insight from the model would be the statistics about family, it's more important than the statistics about variety. If you look at the graph on the screen, it measures how much percentage increase in mean square error there is if we were to exclude a particular variable in random forest. That is a measure of the variable importance. We can see that, in general, the statistics about family, it's more important than that of variety. Looking at the same graph, we can get our second insight. That is, customers prefer varieties with stable yields. We can see that the variables that captures the variation of experimental yields are pretty important in random forest. In fact, this result is consistent among all our 3 models. And moving on to our last insight, I would say it's a pretty surprising one. In general, you might expect a positive relationship between relative maturity and sales. However, our model suggests that this relationship is not monotonic. And we are able to come up with an optimal range of a relative maturity. The graph shown on the screen is a partial dependence plot in random forest. It measures the marginal effect of relative maturity in predicting sales. And we can see that sales is the highest when relative maturity is between 2 to 3.5. Similarly, we can do the same thing for other variables, and we are able to come up with what we call an elite profile of varieties. Those variables might include family average, family variation, variety variation, and relative maturity. In fact, these 4 are the 4 most important variables in random forest. And remember, we have identified 4 elite varieties. And if we were to plot the values of these 4 varieties on the graph, we will see that they are pretty consistent. That means even though these rules may look simple, they are powerful. And you may use it for things like quick screening of your varieties without actually going through so much trouble that I just did. But it's pretty accurate. So, to sum up, I'd like to offer you 3 reasons why our team is the best in town. Hopefully. First, we get a balance between data size and granularity. And we do that by introducing statistics on the family level in addition to variety level. Second, we get a balance between risk and return by putting ourselves in the shoes of our customer. And we introduce a variable that captures how stable the experimental yields are to predict sales. Last but not least, we get a balance between prediction accuracy and model interpretability. And we offer you 3 general insights for you to choose the elite varieties and understand what is really going on behind those models. With that, I would like to end our presentation and welcome any questions that you may have. Thank you.